Good evening, everyone. Am I audible?
Yes, ma'am, you're audible.
No. Sushmita will wait for a few more minutes.
Sure, ma'am.
Yeah.
Students, I request please inform your friends to join the session as soon as possible. We'll wait for 5 more minutes. Within that, please inform your friends to join the session.
So, can I start?
Yes, ma'am, you can start.
Okay,
I'll
fine.
start sharing it.
Okay, good evening, everyone. Okay, good evening, Naimish. So, yesterday we completed with, good evening, Jyoti. So, yesterday we completed with the files, okay? But still, okay, there are some topics of the files remaining, so we'll continue with the files topic, and then the important topic again, okay, we'll be going through, that is the preprocessor and the dynamic memory allocation. And then we will have again today quiz, okay, as I had said that we will have a quiz, okay, because see, tomorrow will be the last session, okay, as per the training schedule. So the topic which will be remaining for tomorrow will be error handling, a very small topic. Then we will be going through one, a mini project, okay, case study, demonstration on that, and one mini project, okay, which I will be assigning to you so that you can work on that later. And the final quiz, okay, we will be having tomorrow, right? So let us start today. Okay, we will first go through the recap of what we did yesterday, and then we'll continue with the rest of the topic, right? So I'm sharing my screen. And yes, the assignment topics for the previous, the topics are assigned. Okay, so there are some assignments which are left. Okay, so that I will be assigning. Okay, by tomorrow you will be getting all the assignments, all the projects. Okay, the mini project which you will be doing later. Okay, based on all the topics, right? So let's continue. I'm going to share the screen. Okay, so this is the slide, okay, which is containing all the different types of the input output we have done. Okay, so we have got character, string, formatted, and binary input output. Okay, so all these 4 examples we have done yesterday. So I'm just going to go through the various functions, the purpose, okay, and what are the example use cases for all these. So if you talk about character IO, okay, it is going to be written in a human readable format. Okay, so we have got the f get c function for reading, f put c function for writing, and this is going to read and write one character at a time. Then the example use cases is copying the file or counting the characters, writing the characters, okay? Then we have got string IO, which is going to read and write a complete line or a string, okay? So again, it is going to have the functions as f get s and f put s, okay? It is understood. If it is an s, it is a string. If it is a c, it is a character. So read lines from files, or when you want to write the logs, okay, or text, you will be making use of the string IO. Formatted input output, okay, so this one example we have seen where we are going to use the formatted data. So again here, if you will see, there is an f print f, okay, that means formatted scan or print you need to do. So one example we did was the student marks. Again, you can have the logs and where you need to read the structured records. Then finally, we have got the binary IO, where the contents are not written in the human readable ASCII, but it is going to be written in binary, okay, which is not human readable. But when you are going to read this, okay, it will be properly, read, okay, and it will be displayed, okay, in the human readable format. So it is going to read the binary block, okay. It is basically used for reading the structures and arrays, and fwrite is used for writing the binary blocks, okay, so saving or loading the records in binary. And then we have also understood about how this reading and writing is happening, okay, not directly when these functions are used, but it is going to make use of the buffer, okay. So buffer, which is a temporary storage in RAM, okay, so this buffer is going to be used, okay, for reading and the writing purpose, and usually the size of this buffer is a 4 KB block, okay. So instead of having every time for every byte, the reading and the for reading and writing, the operating system function being called, okay, so this is more efficient, okay, that is what the buffer, okay, reading and writing, because it is going to read and write in blocks, right? Now after this we are going to understand what is the random access file. Now in all the above example, okay, the reading and writing is being done in a sequence. Okay, there is a sequential access, means one after the other. Okay, so random access allows jumping to any position in a file using the file pointer. Now you want to read or you want to write to or from a specific location. Okay, so how that is possible? So that is done by using the random access file functions, right? So we have got ftell. Okay, get the current byte position of the file pointer. So there is a function f10 which is going to accept the file pointer. It is going to return the long. Okay, that is nothing but the byte position. So return value current position in bytes or -1L on error. So example is ftell fp. That means, okay, it will tell you what is the current location, okay, of this particular file, in this particular file. Then there is the fseek. Okay, now seek means you will be placing the pointer to a specific location where you want to perform the read and the write operation. Okay, so int fseek, it is going to use the file pointer, then long offset and int origin. Okay, we will see what is the meaning of origin. So in the offset, you specify the offset. Okay, maybe it is 5 or 10. Now int origin means from where, whether from the beginning, whether from the end, or whether from the current location. 0 on success, non-zero on error. Now fseek fp comma 10, okay, that is the offset, and seek underscore set. Now this is one of the seek position. Okay, next slide we are going to discuss that. Rewind, move file pointer to beginning. Okay, so again it is going to go back to the beginning. So void rewind file. So see, the return type is void. Okay, because it is going to make the pointer again position to the beginning, right? There is no return value, and the function is what? The syntax rewind, and then you will be having the file pointer. Okay, now this fp is nothing but it is a file pointer instance created for the file structure. Okay, now let us understand what is this particular seek and what are the different the positions, okay, or the origins we can specify here. So the parameter for the fseek, okay, is first is the fp. Okay, if you will see, first is the file pointer, then we have got long offset. Okay, so then offset number of bytes to move. So here fseek file pointer comma 5, that means moves 5 bytes. Okay, then origin, the starting point of the movement. Okay, so from where, okay, we need to start the reading or writing. So seek underscore set is 1, seek underscore current, seek underscore end. Okay, now these three are the value for the origin parameter. Now what that means, okay, so seek underscore set constants means you need to start from the beginning. Okay, start of file. So move from beginning. So how you're going to write that? Fseek file pointer 0 seek underscore set. Okay, that 0 is given, that means it is the beginning. So seek underscore set. Then if you want to read or write from the current position, then you are having the constant seek underscore cur. That means it is the current. So move forward or backward from the current location. Okay, so there is fseek file pointer -5 seek underscore current. Okay, so positive or negative. So if it is a -5, it is going to move backward from the current position. And then end of file, that is nothing but seek underscore end, which is going to move from end of the file. Okay, so fseek file pointer, okay, -10 seek underscore 10. So move 10 bytes backward. Okay, but from where? From the end. Okay, so these are the various constants, okay, values you can set, okay, for the last parameter of this fseek function. Okay, so now let us understand how you're going to do this. Okay, so one program I have already written, so we will be running that. So sequential access means, okay, you are going to read one by one byte. Okay, so what previously we have done, okay, So that is a sequential access, right? From the beginning till the end, every byte is going to be read or every byte is going to be written in sequence, right? And if you talk about random, okay, so anywhere, okay, so if it is here, then you want to move it to this particular position, again you are coming back to this, then you are moving to this location, like that. Okay, so this is known as a random access, correct? Now, suppose this is the file content. Okay, so we have got the content like this, and this is the byte index. Okay, now ftell, okay, ftell function is going to give the current index. Okay, what is the current index? Then fseek moves pointer anywhere. Okay, so where you want to move the pointer. Okay, initially it is here. You want to move the pointer to this particular 2. Okay, so it will be moved to this 2, right? Then rewind moves pointer to index 0 again. Okay, so file pointer, we have got 0 till 10, 20, 30. This is end of file. So this ftell will give the current position. Okay, ftell is going to give the current position. So this is how the random access is done. Now let us understand this with one example. Okay, so here I have got the example for the random access IO. Okay, so let us understand this and we will see the output. Okay, so here the explanation is also written, okay, for you. Later on you can go through this. Now again, okay, I am going to reiterate this. So when you will be using the file, you have to always first create the file pointer. Okay, the pointer for the file structure. Then we are making use of the character. So one variable char ch is created. Okay, now create a file with the sample text. Okay, so fp is equal to f open sample.txt. Okay, and what is this w? This is for write. Okay, remember that if the file does not exist, okay, it will get created, right? Now I want to just write these characters to the file. So what we are using, we are simply using the f put s. Okay, 10 characters. So the index will be from 0 to 9. Then we need to close the this particular pointer. Okay, so that this is written to the file. Okay, so yesterday we understood about what is buffering and what is the use of the f close. Okay, now once the writing is done to the file, now we need to open the file for reading. Okay, so we are going to make use of f open sample.txt and mode is the r, that is for reading. Now first is, okay, seek underscore set. Okay, so move from start of the file. So what is written here? F seek file pointer 2. Okay, that means we want to position the pointer to the offset 2. Okay, so seek underscore set. Right, now the starting will be 0, so it will move to 2. Okay, so if you start from 0, 1 and 2, so it will move to C. Okay, now we want to get that character. Okay, so ch is equal to f get C file pointer, and we will be printing, okay, what is the character at the position 2. Okay, so this is going to be printed. Now second is, we will understand what is the seek underscore current. Okay, so move from the current position. Understand currently, okay, the position set is index 3, right? 0, 1, 2, because we have moved from 0 to 2 here. So when you are writing fp to seek underscore current, that means from the current we need to move, okay, 2 index ahead. So currently at index 3 plus 2, so index is 5. So now it will be pointing to f. Okay, again you read the character and display that. Then finally we have got the seek underscore end. Okay, now if you want to read backwards, okay, now if you are using the seek underscore end, move backward, okay, by using minus, right? So minus 3, so third character from end, so index 7, it is going to print h, right? So now here printf, because it is moving from end, understand, it is moving from end. Okay, so we will print that, close the pointer. Okay, so if you see here, initially we are only writing this character. Okay, and this is the index position from 0 to 9. So 6 set position 2, it is going to print this particular character at the second position. Plus 2, okay, it will be printing this, okay, because currently at 3, it is going to print then F. And then from the end, minus 3. Okay, so from the end, minus 3, it is going to print H. Okay, so now let us understand the output of this. So this is the random access dot C. Okay, so let us run this. So already I have opened the command prompt. So gcc random access io.c. Okay, and let us write A. Okay, so we should get the output, okay, whatever has been mentioned, because we are moving the pointer like this. Okay, so this is how you will be reading randomly from a file. Okay, so just make use of the proper, the origin, okay, in the fseek, right? Fine. Okay, so this was random access file. Then let us come to the last topic of the files, that is the command line file operations. Okay. Now, see, now till now, okay, whatever problems we have done, okay, we are not passing anything to the main function. Okay, this main function, we are not passing any parameters. Okay, but main can take the arguments. Okay, now what are that arguments and why? Okay, we should use the command line argument. So this is known as the command line arguments, which will be actually taken, okay, through the main method. Okay, through the main method. See, we have understood how to pass the parameters or arguments, okay, to the various functions, okay, that we have done in the functions topic. Okay, but now what about the main? Okay, so let us understand what is the command line argument. Okay, command line file handling in C refers to the practice of interacting with files using the arguments passed during program execution from the command line. Okay, that means when you are writing A, okay, after that you are going to pass the arguments. This allows for dynamic and flexible file operations. Okay, now what is the meaning of dynamic? So we are not writing the file name in the code itself. Okay, so now what is happening? Okay, till now what we did, we have mentioned the file name, we have hard coded the file name in the program itself. Okay, like I want to open students.data file or sample.txt or demo.txt, employee.txt, like that. Okay, but now we want to make this dynamic. Okay, and we will ask the user to enter the file name at runtime. Okay, the file from which the reading has to be done, or to which the writing needs to be done. Okay, that has to be dynamic, so that we can take it, okay, into the main method. Okay, main function. So this allows for dynamic and flexible file operations without requiring user interaction within the running program itself. So what is a command line argument in C? The main function in C can be declared to receive the command line arguments. Okay, so what it is? So when we are writing int main, the first is int argc, second is the char argv. Okay, now this is an array. Understand, this is an array. Okay, so argc, argument count. Okay, so argc is nothing but the count. Correct, stores the number of arguments including the program name. What is the program name? So suppose if I'm giving the program name as random access.c, okay, so this is going to be stored at the index 0. Okay, so argc will be total count of the number of argument including the program name itself, right? And second is the argument vector is an array of strings where argv0 is the program name, argv1 is the first argument, and so on. Okay, so the first parameter is the argc, which is nothing but total count of the arguments, and argv is the argument vector, which is going to store the number of arguments given at runtime. First always is the program name. Okay, now what are the advantages of passing the command line argument? First of all, automation facilitates scripting and batch processing by providing file paths and options directly at the time of executing the program. Flexibility allows the program to operate on different files without recompilation, because if you are making the changes in the code, so first I had written sample.txt, okay, I have compiled, I have run the program. Now I want to change the file name. Okay, so now I'm not using sample, I want to use the employee.txt. So what I will do, I will go to the file, I'll make the changes in the code. What I need to do, I need to recompile that file again. Then only, okay, that employee.txt file will be considered, right? But in this case, you don't have to recompile. Just go on passing the arguments, different file names. Testability simplifies testing by providing consistent input through the command line. Okay, so it is also good for testing, right? So that you can provide the input from the command line itself, and then you can test the program. So now how you're going to perform this? So for this also, okay, there is one file created, that is a command line argument, okay, command line io.c, right? Now, let us understand this. So what we need to do here, okay? So this is an example where we are going to provide two arguments, okay, at the time of execution. We need to copy the contents from file 1 and we need to write the contents to another file. Okay, understand, copying the contents from one file and writing the contents to another file. Now this is what two things we need to do. Okay, now in this case the argv will be having three values. argv0 will be the program name itself, one will be the file 1, and second will be the file 2, in which I need to copy the contents. Okay, so here now when you are going to write the main function, okay, you will be providing these two parameters. Okay, so first of all we are checking whether the arguments are given or not. So if argc is not equal to 3, understand, argc is nothing but the count of the arguments given. Now we want two files and one will be the program name by default. So total argument should be 3. So if argc is not equal to 3, okay, we are simply giving usage. We need to copy the source file and the destination file. So we need to provide two parameters. First is the source file to copy and destination file where to paste that. Okay, and we will be returning 1, okay, because there is an error. Now after that, we are creating file pointer is equal to f open. Now understand, this is what is making this this particular program dynamic, because we need to open the file, but the file name is not written here. It is not hard coded. Okay, so what we are writing, argv of 1. So from this file we need to read. Okay, so it is open in the read mode. Remember why 0 is not written? Because 0 contains the program name itself. Okay, if source equal to null, printf error cannot open the source file. Okay, now okay, one more thing what you need to know, if you need to read from a file, that file should be available, that file should be present. So in this case, if the file is not available, that means the source is going to point to null, source will be null. Okay, so this error you will be getting. Second is where you want to copy the contents. Okay, so we are creating the pointer as destination is equal to f open. Now which file? The second argument file, and we need to open this file in the write mode. Okay, so the mode given is w here. If destination again is null, then cannot open the destination file. Okay, and f close the source. Correct. Return 1. Int ch while ch equal to f get c. Now understand, if the file is available, then in the character, we are going to read the character by character from the source file till it is not reaching to the EOF, that is your end of file. What we need to do? F put C character in the destination. Okay, so we need to read from the source and we need to put that into the destination. This is how you're going to copy. And finally, you will close both, okay, the source also and the destination also. And we are simply giving contents returned to the file successfully. Okay, so which file? To the destination file, right? Whatever name I will be giving. So this is the code for the command line. So main here is that main function. Okay, this is going to take the arguments. Okay, now let us understand this one by one. Okay, so this is your command line io.c. Now look here. If I don't give any parameters at runtime and I simply write a here, okay, I will be getting the error line number 7 because the argument is not equal to 3. Okay, so usage copy source file to destination file. This is the error I have got. So now what I will do, so let me specify that I want to read from file 1.txt. Okay, and I want to write to file 2.txt. So I want to copy the contents from file 1 to file 2. Okay, so when you're providing this way, the arguments at the time of execution, okay, so this file 1.txt will be the argv of 1 because 0 is the program name, and file 2.txt is the argv of 2. Okay, now I have given both the files here. I'm going to press enter. Now what is the error I'm getting? Cannot open source file 1.txt. Understand, file 2, if it is not present, it will get created because the mode is W. So W means what? If the file does not exist, this file is going to be created by the operating system. Okay, if it is there, the contents are going to be overwritten. Now, but file 1 has to be there because we need to read from this file. So it is not going to create now because the content needs to be read. So this file needs to be present. Now this file is not available. Okay, so let me just create this file. So this is file 1. Okay, so so here I will be creating this file 1.txt. Okay, so you can directly write the comment. Okay, the notepad file 1. Okay, so it will open the notepad.exe and you see that notepad file 1.exe is getting created. Okay, now we can write some contents here if you want. Okay, so let me just go to this. Okay, and what I will do, this is the command line. Okay, so I can simply go ahead and write something like, okay, let me just copy this itself. Okay, this is my content. Okay, and I will not be printing everything, but just something here I will be writing. Okay, let this be first line. Okay, this code will demonstrate the command line. Something like this I want to write. Okay, so now I'm going to save this file 1.txt. Okay, close this. Correct. So file 1.txt is there. Now if you go to the C programs, okay, so let me just go to the C programs and day 12. Okay, so here you will see that file 1 I created. Okay, file 1 is created here. Fine. Now let me go back and run that. Okay, so a file 1.txt, file 2.txt, it should write. Okay, so now I'm getting contents returned to file 2.txt successfully. Okay, so this file 2.txt got created. Okay, so let us see what is the content of this file 2. Okay, so this is the contents of the file 2. This is what I have written in file 1. Okay, so this is how you are going to make use of the command line argument. Okay, so let me just, yeah. So this is how you're going to make use of the command line argument. Okay, understood everyone till here? Is this clear? Is this clear, everyone? Jyoti, okay. Akshaya, okay. Certificates you will get after the training. Okay, I hope this is understood to everyone. Okay, what is the random access? Okay, .io. What is random access.io? And what is the command line IO? Okay, what is the command line IO, right? So this is better because you can provide now the file, whatever you need to write. Now what files I have got? Okay, so let us say I have got the sample. Okay, sample file is available. So if I will now give the file name as sample, okay, sample.txt, right? So contents returned to file2.txt successfully. Okay, so this is okay, more efficient, okay, dynamic, because you can go on giving any file name at runtime. You don't have to recompile the program because these files are not hard coded in the program. Okay, so contents are written to the file2. So file2 will be overwritten to the new contents because we have not mentioned append. Okay, so this is the new content written to the file2.txt, right? So this is how you are going to make use of the command line file operations. Okay, so till here, okay, all the file okay functions are completed. Now there is one particular example which I will be demonstrating. Okay, there are few functions written in that. So this is a student management system.c. Okay, student management system.c, right? Now this includes your what menu driven application, where we will be performing addition, deletion, searching, okay, of the student record. Since we need to write the student structure, we are going to make use of the binary input output, okay? And menu driven, so we will be asking the user what needs to be done, what operation needs to be done, till user is going to enter the choice for exiting from the application, okay? So we need to make use of here string.h, right? So let us take the same example. So we are going to make use of student structure with roll number, name and marks, okay? Now the various functions are created here. So we have got the add student function, display students function, okay, search student, right? And delete student, okay? And we are going to make use of a menu driven okay program here, fine. So first of all, we had created a structure. Now let us come to the main, okay, with this menu, right? So while one, because one is what? While it is always true, correct? So printf student record system we are creating. So first is adding, second is displaying, third is searching, deleting and exiting. Okay, so we are going to ask the choice of the user. You will take the choice in the choice variable. Now the switch case, you already know, we are going to make use of this 5 different case, and with every case we are going to call that particular function. Okay, so first is add a student, display, search, fourth is delete, and fifth is return 0. Okay, and default is invalid choice, right? Return 0, it is going to come out of the program, okay, and you will be getting back your prompt. So now let us go to the case 1 where we need to add a student. See, initially if you call display student, nothing is going to display because there are no records, correct? So let us go to the student. So here all the functions are created. So one by one we will understand. So this is the add student function, okay, display student, then search student, delete student, okay, and this is your main function, right? So 4 functions are created. Okay, now one by one I will be going on collapsing this, okay, and we will understand the code. So if you go to the add student here, first of all we have to create the student variable, that is a structure ka variable, create a file pointer, So what file we are creating? The students.dat. Okay, so let us say this file is created and we need to open this file in the binary. Okay, so append binary. Okay, so now I will be creating another file here. So let us say this is the student record dot dat. Okay, so I'll be using student record. Okay, if not fp, okay, if not the file pointer, that means if it is null, error opening the file return. Okay, so you can also make use of this if condition. Then we are going to ask user the student details because we need to add them to the file. So except roll number, name and marks. And then for binary, we are going to make use of this fwrite. Okay, so fwrite, the address of S, size of one record and the file pointer. Finally, you close the pointer. So this record will be successfully written. Okay. So this is add student. Now let us come to display student. Now what is display? We simply need to display all the records. Okay. So again, we are going to open the file, which is a student record. Okay. Change the file name. Okay, you can change the file name or you can keep this itself. Okay, once you're getting this. Now I want to open this file for the reading purpose. So read binary. Okay, read binary. Now if not file pointer, no records found. Okay, if it is not, there is no records found, return. Printf, otherwise you will read and you will display. Okay, so while f read, now see, understand this particular reading. Okay, we are going to write in the while loop. So while this is being read, okay, we will be printing all the records. Okay, close this. So this is how you are going to display or read. This is nothing but read. Okay, the function name is display. Then we need to search for a specific record based on the roll number. Okay, because roll number will be the primary key. Okay, so here we are using the student int roll found is equal to 0. Remember when you perform the CRUD operation, okay, so the CRUD operation, in that your delete operation, search operation and update operation, these three operations will be working on the primary key, which is the roll number, because roll number is going to be different for every student. Okay, yes, but then when you are going to add the records, this needs to be checked that the roll number is already added. So the another, the second student roll number has to be different. Okay, that needs to be checked when you are going to add a record. Okay, I'm talking about primary key term, which is used in the databases. Okay, but here also that will hold true. So enter roll number to search. Okay, so we will be first, taking the roll number. Then we are opening this student record dot data file. Okay. Then if not, then file error return. While f read, okay, you are going to provide all the parameters to this f read. If s dot roll equal to roll. Okay. So if s dot roll number we have created, and this int roll, okay, we are going to check. Record found, and for that particular roll number, we are going to display the record. And found, which is initially 0, okay, we are going to make this found flag as 1. See, you can have any other flag set. So this is basically used, okay, in this type of the scenario where we need to find a record, and if it is available, we are going to make the flag value, okay, as 1. Otherwise, it will be 0. Okay. If not found, okay, if not found, so this is the roll number which is taken from the file. If it is there, and the roll number which we have taken from the user. Okay, so user want to get the record for this roll number. So if the s dot roll, if the roll number is there in the file and that matches the roll number what the user had given, then we will display the record and the found flag is going to be 1. If not found, okay, record not found. Okay, if it is 0, close the pointer. Okay, so this is how you're going to search for a student, and once you have searched, then you can perform the update on that, delete on that as well. Now second is the delete student. Okay, so here again enter roll to delete. Okay, roll number. Here I will make the changes. Okay, so this will be the students record dot dat. File temp is equal to f open temp dot data file. Okay, now there is another temp dot data file which is open for writing. Okay, if not fp or not temp, file error return. While f read, okay, you're reading, and if the roll number is available, found is equal to 1. Okay, skip this record, else f write size 1 temp. Okay, and then we are going to close this. Remove the student's record, okay, dot dat, and rename temp to the student record. See, we are not deleting or removing the data file completely. We are going to rename the temp dot data, okay, to the student record dot data, so that your record is there. Okay, so if s dot roll equal to roll, found is equal to 1. Okay, else we are going to write that to the temp, and then we will remove the student record dot data file. Okay, so we are actually making use of the temporary no database here. Okay, so that we can write the record to the temporary. Okay, all the records will be written to the temporary, and then we are going to rename that temporary to student record. Okay, and then that record which is left in the student record dot data file, that will be removed. Okay, so if found, printf record deleted successfully. So if the record is found, understand you need to skip this record, found is equal to 1. Else whatever other records are there, that you are going to store in the temp. Okay, we will remove the student record which only contains the searched record, which needs to be deleted, and then we will rename this temp.dat to student record. Okay, so this is how the deletion is done, and from the main, okay, we are calling this function. Fine. So let us now run this student management system. Okay, so let us go to the student management system.c. Okay, so look here. Now we are getting this menu: add student, display, search, delete, and exit. Now enter your choice. If I'm going to write 2 here, okay, so I am getting no records found, right? Now let us add a record. So enter the roll number, okay, enter name. So let us say this is again student 1, and enter the marks. Okay, again I will add a student. Okay, so enter roll number. This is the second student added. Okay, and enter the marks. Now if I go to display all student, that is the second. Okay, so you will see here 2 records are displayed. Okay, and yes, your student data file is created. Okay, but this is in binary. Then I need to search for a student. Okay, let us say I'm giving a roll number as 103, which is not available. So I will be getting record not found. Okay, then search again. Let us write 102. Yes, so 102 record is found. I'm getting that. Okay, now I want to delete. Again, if I'm going to write 10, let us say 4. So I will be getting record not found. Okay, and if I'm going to delete the record 102, okay, so I'm getting record deleted successfully, right? And now if I will go on displaying, so we have got 1 record available. Okay, 1 we have deleted. And if I press 5, okay, we are going to come out of it because exit. Okay, so this is how you have to, create a C application. Yes, you can implement later on here the logic for how you're going to update the record. So let us say if the student marks needs to be updated. Okay, so that operation also needs to be written. Okay, but this is how you have to create a menu driven application with files for the CRUD operation. Okay, is this understood, everyone? Okay, so this completes your file, okay, which is very important topic. Okay, so all the functions we have done, all the types of the reading and writing has been done, okay, in this. Yes, okay, so is this understood, everyone? Yes, okay, good. Fine, so I will close all this. Now let us go to the new topic, okay, for today, what we are going to start. Again, very important topic, dynamic memory and preprocessor directives. Okay, so what are the topics we are going to go through into this? What is static and dynamic memory? What is heap and stack? Malloc, Kellogg, reallocate and free. Very, very important concept in C. Best practices you need to follow, and finally we will go for the preprocessor. Okay, so we have already done, okay, like hash include is a preprocessor directive. Okay, hash define we have done for the constant. Okay, but apart from this there are many other preprocessor. Okay, so we'll be going through that preprocessor also. So first of all, let us understand what is the static and dynamic memory. Okay, because when you learn C, okay, C++, you have to, allocate, deallocate the memory using these functions, okay, malloc, calloc and all. So the understanding of this type of the memory, what is stack, what is heap, okay, what is the meaning of static and dynamic memory, okay, needs to be understood, right? So what is a static memory? Okay, Naimish, which part of that code needs to be explained in the student record? In the student record? Okay, I have closed that. Yeah, student management record. So which particular function you want it should be explained? Add student, display student, search or delete student? Okay, so please mention that. Okay, so I'll come back to this student management, okay, system. Search and delete. Okay, fine. Search and delete. Okay. So if you go to the search student, okay, now that we have already done, okay, about what is the search student here, okay, which is nothing but third. Okay, third is the search student, right? Right. Look here. Fine. So enter roll number to search. Right. Now let us understand this. Now what, first of all, we will be, creating the variable. So first is the int roll number, because we will be accepting the roll number from the user to search, okay, for a specific student. So this roll number will be taken into this roll. Now found is 0, and understand this type of the variables, what we defined is known as a flag value. Okay, so if the search record is found, okay, then we are going to make this flag as 1, else it will be 0. Okay, so whatever roll number you are going to give, that roll number will be taken into this roll variable. Okay, now we have to open the file for reading, and if not file pointer, we will give file error, because this file should be available. Okay, now you will go reading the record one by one. Okay, so let us say these two records are available, correct? Now from these two records, I want to search for this record 103, which is not available. Okay, so why we need to use a while loop? Because it will go on reading each and every record, correct? So while f read, that means still this record, all the records are being read. Okay, so while f read, address of S, that is your student structure, size of S, read one by one record, okay, at a time, and file pointer is pointing to the file. So if S dot roll, understand S dot roll is the roll number, okay, which is there in this particular file, okay. And this roll we have created as a variable which we have taken from the user. So if the roll number in the file is matching with the roll number what the user had given, if it is matching, then we are going to print record found. Like in this case, I have given 102. Okay, so I am getting record found and I am getting the record of the student. Okay, so record found, and I'm displaying the roll number, name, marks. Okay, and then we are displaying the s dot roll, s dot name, and s dot marks. Okay, from the file name. And if the record is found, I want this particular found flag to be made as 1 to make the code break here because the record is available or the record is found, so that it should not go again for reading the other record. Okay, that is why this flag is kept as 1, because the record is found, and we will be now breaking this loop, correct? But if not found, okay, if not found, that means if it is still 0, then we are printing record not found, and that is what I was getting earlier. See, record not found here. Okay, so close this file pointer. This is how you're doing the search. Now the same thing, okay, you ask for delete. Now what is the delete operation? Okay, the same thing. So if I go to delete, okay, so what is the delete? That is the 4th. Okay, so I have given 4. Now enter roll number to delete. I have given 104, which is not available, correct? So here also the same thing is done. Okay, whatever roll number, okay, user is providing, that will go into this roll variable. Found is 0. You will enter the roll number. Okay, now understand one thing, what is done here. We are also going to open the temp.dat file. See, we are going to read the student record, and the records which are not getting deleted will be stored in the temp.data. Okay, and WB means what? If this file is not available, that is going to be created, correct? So if not file pointer or not temp, okay, so if it is null, then we will print the file error and return. But now if the record is available, now understand, if I have given 104, okay, so 104 means what? It is not available, the student record is not available, okay. And if I'm going to give 102, okay, so f read, okay, read the record. If s dot roll equal to roll found is equal to 1, okay, found is equal to 1, that is what this one. Okay, it is 0, so we are making this found is equal to 1. Okay, skip this record. Okay, so if I'm giving 102, now please understand this particular logic. If we are going to enter the roll number to delete 102 and 102 is available, okay, because 2 records are there. So this 102, okay, we are not going to delete at this moment. Okay, so if this record is found is equal to 1, so found flag is going to be 1, but skip this record, else f write the other record. Now what is the other record remaining? 101. So this 101 record is written onto this particular f write, that is your temp file. Okay, now this will go on. So if I have got 3 records, the one record which I want to delete, okay, we will not be doing anything here, else f write that records, close the pointer, remove student record.dat. Okay, remove this particular student record.database file because it contains the record which needs to be deleted, and rename the temp.dat which contains the other records to student record.data. So student record.data will be as it is, okay, with the other records. And then we are going to print that record deleted successfully or record not found. Okay, record not found, initially I am getting the output here now. If I am giving the roll number which is not available. Okay, so this is what is the search and the delete, okay, code, right? Is this understood? Naimish, is this understood now? Is this clear? Okay, fine. So let us continue with our next static and dynamic memory. Okay, so static memory is allocated at compile time, includes global variables, static variables, and literals. Okay, lifetime entire program run, size fixed at compile time. Okay, so what is the lifetime of these type of the variables? Okay, the lifetime is till the entire program runs. Once the program is run completely, then these particular variables, okay, will not be existing. Okay, why? Because they will be used only till that particular program run. And the size of this particular static memory is fixed at compile time. Like we are writing int x is equal to something, 4 bytes is there, okay, or all the primitive data types. Now dynamic memory is allocated at runtime from the heap using allocator functions. Okay, now what are these allocator functions? Malloc, calloc, realloc. Okay, now these functions are going to allocate the memory at runtime on heap. So there is a stack and there is a heap. Okay, so we will understand what is this memory. Lifetime controlled by the program must be freed. Freed means you need to first of all allocate the memory, okay, for this dynamic variables, whatever you'll be using, by using malloc, calloc, and realloc. Okay, so you have assigned the memory, you have allocated the memory. Now it is your task to release or deallocate the memory, and that will be done by using the function free. Okay, useful when required size is not known at compile time. When you will be using this, when the size is not known at the compile time. Okay, so static means which is already defined, the size is known. Okay, it is going to be initialized at the compile time. Dynamic means what? The size is not known at the compile time. It is going to be allocated dynamically by using malloc, calloc, realloc, but it needs to be freed by using the free function. In case of static memory, it will be automatically free when the program exits or the program run completely. Okay. So now when we talk about static memory, okay, there is a stack. Okay. Now stack allocation happens in the function called stack, where each function gets its own memory for variables. Like in this case, if there is a main function, okay, so we have got int a, b, then n or ch, okay. All these variables get memory allocated on stack because the size is known at compile time. Within the functions, whatever variables are created, that will be on the stack. Okay, so stack allocation happens in the function called stack, where each function gets its own memory for variables. Stack allocation is the process of assigning memory for local variables and function calls in the call stack, because you're going to call different functions, right? So all that will be in the stack. It happens automatically when a function is called and is freed immediately when the function ends. So all this will be allocated memory in the stack, and once this function will exit or it will come out because the program execution completed, the memory is going to be freed, and this is going to be done automatically. Okay, you don't have to take care about it. Since stack memory is managed by the system, it is fast and efficient but has limited space compared to heap allocation. So if too many function calls exceed the stack's capacity, it results in a stack overflow error, because for the execution of the function, memory is required. So if memory is not available for the function execution, then the exception, which is the stack overflow, okay, that will be thrown. Okay, so there is a limited memory. Now, if you go through the working of stack, memory is allocated in contiguous blocks within the call stack. Contiguous block. Okay. The size of memory required is already known before the execution. Okay, we know what is the size of this predefined types. Okay, the local variables which are defined inside. When a function is called, its local variables are allocated on the stack. Once the function finishes execution, the allocated memory is automatically freed because memory is used. Okay, so that memory will be automatically free, and this is done by the system, okay, by the compiler. The programmer does not need to handle allocation or deallocation of memory. Since stack memory is freed when a function completes its execution, it is also called temporary memory allocation. Okay, so all these variables get memory allocated on stack, okay, because the size is known at the compile time. Okay, so remember that whatever is there on the stack, okay, your function call stack, all the variables, local variables, okay. So this memory allocation, deallocation will happen by the system. Okay, so programmer doesn't need to handle this. But on the other hand, if you talk about the heap memory is allocated dynamically during program execution. Unlike stack memory, heap memory is not freed automatically when a function ends. So what you need to do, you need to call this free function, okay, so that the memory is free, okay, and it is available for the other program execution. It requires manual deallocation in C or C++, or if you talk about Java, .NET, Python, there is garbage collector available. Now, garbage collector, okay, will run and it will deallocate the memory for the objects which are not in use. Okay, that is something different. If you go for learning the garbage collector and you go on learning what are the objects, instances, then there are 3 generations of objects. Okay, generation 0, generation 1, generation 2, then the variables, the temporary variables will get allocated on this particular generations, and there is a algorithm which is followed by the garbage collector to find the objects which are not in use, or the objects which are not referenced by any other object, that will be removed. But that is completely a different concept. In C, what happened? Heap is a memory, okay, which is given at runtime. Okay, so C is not behaving like the other. In C, heap means what? It is the memory which will be dynamically given, okay, allocated when you are making use of malloc, calloc, and realloc. Okay, so heap refers to a large pool of memory available for dynamic allocation. C runtime does not track object age or automatically free memory. Programmer manually manages the memory, and all this allocation, deallocation is done by using these 4 functions. Okay, so in C, you need to be aware of these 4 functions, okay, which are very important. So examples of data stored on heap, dynamically allocated variables. Now, if you see this, okay, we will understand, okay, what is this particular parameters given to this functions, okay. So we have got int pointer is equal to malloc size of int, okay. So this is nothing but memory allocation. Dynamic arrays, okay, if you want to create the arrays, then also you will be using this. This is the size. Structure stored dynamically. Okay, you want to store the structure dynamically depending on whatever is the size of the structure. Dynamically allocated strings, linked list nodes, trees, and graphs. In data structures, you will come across this linked list, nodes, then trees, graphs, okay, because there are different type of the data structures. So dynamically memory is allocated here, okay, and when you are deleting a specific node, the memory will be freed, okay. So that is done dynamically. Linked list is a good example where unlike array where you need to manage the memory, you need to shift the elements because it is stored contiguously in the next memory address, okay. Whenever you are adding, deleting, you need to shift, you need to resize the array and all. This is not done in the case of linked list. Dynamic memory allocation is done, pointers is used, okay, which will refer to the next memory address. Big buffers, okay, so there also we will be making use of the heap, okay. Now these are some of the examples, right? So this is the difference between the heap and the stack, okay. Talking about what is the memory allocation type. Stack, it is automatically managed by compiler. Here we have to manage using these functions. Happens automatically when the function is called or returns. It should be explicitly allocated and freed by programmer. What is the lifetime of variable? Till the function returns or till the function completely executes. Exists until freed using the free function. Typical use of stack will be the local variables, function parameters, because function parameters are local, okay. Return addresses, your dynamic arrays, linked lists, trees, buffers, okay. Large data required. Speed is very fast, okay. This is slower. Limited and smaller, few MB depending on the OS. Memory size is limited in stack. Here, large, only limited by system memory. Fixed size known at compile time. Here the size can vary. Direct access via variable name, accessed using pointers. Yes, variables you can directly access, but here you need to make use of pointers. Risk factor, if deep recursion, okay, recursions you are making use of, deep recursion, it is going to call the functions. Large arrays, memory leaks, dangling pointers. We will discuss about dangling pointers, fragmentation, okay, and double free. Compiler control, programmer control. Stack overflow is the typical error, memory leak, segmentation fault. Example is a local variable created. Example is the memory allocated using malloc. Automatically at end of a block or function, the memory is going to be free whenever free is called. Small, short-lived data, large, long-lived or unknown size data. Okay. Now these are some of the differences between the heap and the stack, okay, which you should know. Now let us understand, first of all these malloc, calloc, realloc and free, and then we will see one example to understand all of this, okay, in one particular file. So all these are declared in the standard lib and will operate on the heap, okay. So there is a malloc size t, okay. Now this is already we understood in the last session. This is available as the alias name, okay. Now malloc means memory allocation. Allocate size bytes, contents undefined, okay, garbage. Remember, when you are using the malloc, initially the value for the variables will not be defined, so it is going to give you the garbage value, okay. Returns void star cast optional in C, okay. It is going to return the void. Returns null on failure, Now look at this. This is what is the syntax of the malloc. Okay, so we are writing int pointer is equal to malloc 10 into size of pointer. Okay, so it allocates space for 10 integers on the heap and stores the starting address in pointer P. So 10 integers. You want to allocate the size for 10 integers. Now every parameter definition is given here. So int star p, it declares a pointer to integer. Okay, that we know because it is int pointer. Malloc allocates memory from heap. Okay, that is what is the malloc function doing. 10 number of elements needed. 10 is the number of elements or integers needed because we are not giving the numbers initially, okay, at compile time. So we are providing this number when we need the memory from heap. Okay, so number of elements needed is 10. Size of pointer, size of each integer. Now whenever you are making use of this particular function, see that you are using size of instead of size of int. Okay, you are writing size of this pointer. Okay, this is much safer to write. Then 10 into size of total bytes required. Okay, so what will be the total byte? Integer is having 4 bytes. Okay, so 10 into 4. Assignment stores heap memory address in the pointer. So it will store the heap memory address in this particular pointer. Okay, so what here it is done, it is allocating the space for 10 integers on the heap and stores the starting address in the pointer P. We know starting address of any particular array. Okay, starting will be stored in the pointer. Okay, this is what is a malloc, right? But initially, since these integers are not initialized, malloc will have the garbage value initially. This is the difference between the malloc and the calloc. Next is your calloc. Now calloc is going to take the two parameters, okay, the size and the number of the member variables. Okay, so calloc means contiguous allocation. Okay, allocates n blocks, each of size bytes, initializes all allocated bytes to 0. Understand the difference is this. If you talk about malloc, it is going to allocate the space for 10 integers, okay, which will be taken from the heap. But here, this will initialize to garbage. You will get a garbage value, okay. It is not initialized to 0. But in the case of calloc, memory contains 0 in every byte, including for ints, floats, char, and arrays. That means in the malloc, where the memory contains garbage, in the calloc, memory contains 0. Okay, it also returns void. It will return null on failure. So how you're going to write? If you will see, the parameter here is same, except here we are writing int p calloc 10 comma size of the pointer. Okay, so again here it declares a pointer to int. Calloc allocates 0 initialized memory from heap. 0 initialized. It will not have garbage value. 10 number of elements needed. Size of p, size of each integer. 10 comma size of pointer. So it will allocate 10 into 4, 40 bytes. Assignment store heap memory address in the pointer. Okay, so memory address will be stored in the pointer. Okay, then we have got realloc. Okay, now realloc means resize existing memory block. So if you talk about realloc, it is going to have the void pointer. This is not going to return anything because it is going to resize the memory. Okay, size t new size. Okay, new size we need to provide. So if you have got 5 elements earlier and again you need to allocate the memory for 5 more elements, okay, then that is a new size, right? So this is resizing the existing memory block, changes the size of a previously allocated block. previously allocated block. It may be malloc, it may be calloc or realloc. Okay, it can be done using realloc also. Anyways, but it is going to resize it. Okay, may expand in place. There are two possibilities in this. If you are resizing the memory, it may expand in the same place, or it will move to a new block and copy the old data. Okay, return null on failure. Old pointer becomes invalid if reallocated. Okay, so if it is expanding in the same place, then it is okay. But if it is moving or it is getting reallocated, then the old pointer becomes invalid. Okay, so here if you will see, let us say initially, okay, you have used the malloc, okay, to allocate the memory 10 into size of p, and now you're using realloc the pointer 20 into size of p. That means now you need to assign 10 more, total is 20. Okay, so here realloc means resizing an existing heap block. P, existing pointer previously allocated using malloc or calloc. 20 into size of pointer, new required memory in bytes. So we need space for 20 ints. Realloc the pointer. Attempts to resize the block may move to a new location. It is completely given here. Assignment stores the possibly new address back into P. Now, avoid losing the pointer on failure. This is something which you need to note. Okay, avoid losing the pointer on failure. So you need to always check int star temp is equal to realloc the pointer to the new size. If temp is not equal to null, okay, p is equal to temp. Okay, so you should not lose that pointer. So if temp is not equal to null, okay, then your pointer temp will be initialized to the initial pointer. Okay, so this is what is realloc. Okay, so again understand, malloc means you need to allocate the memory, okay, dynamically from the heap, okay, for this 10 integers. Second is calloc. Again, it is the same, but here the memory will contain 0 in every byte. Okay, not unlike malloc, which will contain the garbage value. Realloc is going to resize the existing memory block. Two possibilities in this. Either the expansion is done in same place or it will move to a new block. Okay, so these three functions are used for allocation of memory. And the last function, free, which is nothing but it is a void pointer, it deallocate the memory. Okay, so freeze previously allocated memory. The heap block is returned to the system. Pointer becomes a dangling pointer after free, which is invalid. Does nothing if pointer is null. So you are simply going to make use of void free void pointer, free the pointer. Okay, and p should be initialized to null, right? So if it is not null, then there will be a problem of dangling pointer. So free releases memory back to heap. P, pointer to previously allocated memory. Free P, memory is deallocated, cannot use the pointer anymore. P is equal to null, prevents the dangling pointer, safe practice. So it is safe to initialize pointer back to null. Okay, this is something which is not required here. Okay, so this is all the 4 functions. Okay, so let us first understand the code, okay, for this. So this is the memory.c file. All the 4 functions are written here. This is the explanation of the code. Okay, so explanation of the code, we will understand from here one by one how this is working, correct? So first of all, let us come to the main function. So the standard lib.h file you need to include. Okay, So first of all, okay, we will discuss about the malloc. Okay, so allocate memory for 5 integers. Okay, we need to now use 5 integers here. So int pointer is equal to malloc 5 into size of the pointer. Okay, so if p equal to null, printf malloc failed, and we will return 1, okay, back to the system. So here what we are doing, we are allocating memory for 5 integers. Okay, 5 integers. Now second, we will print the values after malloc. Okay, now 5 integers memory is allocated, okay, at runtime using malloc. Now we need to print. So memory contains garbage uninitialized. Okay, so here what we are doing, we are now printing the values of that 5 integers where the memory is allocated dynamically. So I equal to 0, I is less than 5, I plus plus, printf this pointer %d, this is the p, and p of I. Okay, so this is the I, okay, %di is equal to p of I. So what is the value that we are printing? Okay, initialize manually. After that, we are going to initialize this manually. So what we are initializing to I plus 1, okay, into 10. So it is initially 0. So 0 plus 1 is 1. So 1 into 10, 10. So P of 0 will be 10, then P of 1 will be 20, like that. Okay, so we need to initialize the value now 10 to 50. Okay. Now n values after manual initialization. Now again we are printing the values after manually initializing them. Okay. So till here, okay, what we are doing, we are understanding the malloc. Okay. After that, there is a calloc. Okay. So let us first see the output of this. So this is day 13. Okay. One by one, if you understand the code, it will be better. So let us move to the day 13. Okay, so let us write this. Oh, sorry, spelling mistake. Okay, so the file name is the memory.c. Okay, so since I've written the for loop outside, so sorry, inside the header. So let us compile this by using -std. Okay, so we are going to write here loop declaration. Yeah, right. See here. Already we did this. -std equal to C99. Okay, so -std equal to C99. Otherwise, you simply write the for loop of int I outside. Okay, fine. So now let us understand only the first output. Okay, so here we allocated the memory for 5 integers. Okay, so value after malloc. Okay, so values after malloc, line number 17. If you see the P of 0, 1, 2, 3, 4, you may get a garbage value or simply this. Okay, fine. See here. So you are getting the garbage value. Correct. But after the manual initialization, so values after manual initialization 10, 20, 30, 40, 50. Okay, manual initialization will give you the correct values, whatever you have initialized. So remember, malloc initially will have the garbage value. You need to initialize. So once you are initializing, you will get the proper values. Okay. Now this is calloc. Now calloc is also the same. So here the pointer name we are keeping is q. 5 integers, comma, size of into q. Okay, what is the difference? Here you are writing 5 into size of pointer. Here you are simply writing 5, comma, size of the pointer. Okay, if q is null, calloc failed. Okay, then free the pointer because this pointer we have used earlier. Nah? So we are freeing that pointer. Okay. Now, when you are using calloc to initialize, to allocate the memory, the initial values will be 0. it will not be garbage. Okay, so look here. Values after calloc, okay, all 0. In the malloc, you got the garbage value, but you will not get this in the case of calloc. Okay, you're going to get 0, right? So all values are 0, right? Now we are using realloc. Now what is the meaning of realloc? Reallocate the pointer initially, what we did with the malloc, to store 10 integers. So initially we use the pointer p in the case of malloc to store 5 integers. Now we need to reallocate the pointer to store 10 integers. Okay, so what is the realloc? So first you need to give the pointer, comma, 10 into size of that pointer. And we are now using a third pointer, which is a star temp. Okay, so if temp is null, realloc failed, old memory still valid. So we will free the pointer initially used with the malloc and free the queue which we have used with the calloc. Okay, and return 1. Now reassign pointer only after success. Now if this realloc is success, then we will reassign the pointer. So temp, okay, so in temp we got now the memory for 10 integers. So that we are reassigning to p, which is used in malloc for 5 integers. Now we are reassigning that p pointer of malloc for 10 integers. Reassign only if it is success. Okay. New extra memory indices 5 to 9 because 0 to 4 was the first pointer. So 5 to 9 will be uninitialized. Okay. So again, if you will see the 0 to 4, we have already initialized 0 to 4 in the malloc. Okay, now the same malloc pointer is reallocated for 10 integers. So rest of the 5 will be having the garbage value. So we are getting rest of the 5 as the garbage value. Okay, from 5 to 9. This is the garbage value, correct? Then we are initializing the newly added values. Okay, so now we will start from I is equal to 5. So we are starting from 5. Okay, so 10 to 50 already was given. So from 60 to 100, now we are allocating. And then we are printing those values here. Okay, and finally, you need to free the memory. Okay, you need to free the memory. So we will be using free p. P is used with the malloc. Free q, which was used with the calloc. Okay, optional but recommended. You should initialize these pointers to null. And then we are getting memory freed successfully. Okay, so now at the end we are getting memory freed successfully. Okay, now here there are certain points written. Again the same thing. Whatever I've explained, malloc is going to allocate memory for 5 integers. Contents are garbage. Values are initializes manually. Calloc allocates memory for 5 integers. Okay, see here. Allocates memory for 5 integers. That is calloc. Okay, contents are all 0. No manual initialization needed. Then realloc, it will expand the malloc. Okay, from array 5 to 10. So first 5 values are preserved because that is what already we have initialized. Next will be garbage. So we need to again reinitialize those. Okay. Now the important point, when we are using this free function to free the memory allocated, okay, after that we are initializing these pointers to null. Okay, now why that has to be done? Freeze memory allocated. Setting pointer to null avoids the dangling pointer issues. Now what is this dangling pointer? A dangling pointer in C is a pointer that points to a memory location that has been deallocated because we have written free P and free Q, okay, and is no longer valid. Means the memory the pointer references might have been freed back to the operating system. reallocated for another purpose, because that memory can be used by to run another process. Okay, so it may have reallocated for another purpose or simply gone out of scope. So dereferencing a dangling pointer leads to undefined behavior. So if you are not initializing null to this particular pointer, okay, it may reference to the particular memory location, which will lead to undefined behavior. Okay, so that is why this is important, okay, to write after you free the memory. Okay, now the same example we are going to understand, okay, from here. This, okay, now understand how this is getting allocated, right? So first of all, here I have already mentioned, okay, what is that fragmentation and what is getting stored on the stack. We know that local variable function calls will be stored on stack. When you write int star p, pointer variable will be stored on stack. Int q, pointer variable stored on stack. Only the addresses of heap memory are stored in these pointers. Addresses are stored, okay? Stack does not store the actual integers allocated. Addresses will be stored. Heap, dynamically allocated memory. So when you are using malloc 5 heap memory for 5 integers, heap memory 5 zeroed integers, reloc, heap memory resides to 10 integers, okay? Actual integer values will be living here. Initially garbage malloc, 0 initialized calloc, preserved old values plus new uninitialized values realloc. Okay, so now the same particular example, understand diagrammatically. So when we are using this malloc for allocating 5 integers, okay, so we are having this 5 pointer initialized. Okay, heap is going to provide you the memory, but it will include the garbage value. Okay, so contents are undefined. You have got the garbage value. So you need to manually initialize. So we have manually initialized, and now 10 to 50 values, meaningful values are provided. Okay. After that, we have used the calloc. Okay, now calloc means what? Here you will be getting all 0 valued. Okay, so we are getting q, okay, which is all bytes are 0. It will not contain the garbage value like this. Okay, then realloc, it is going to resize the pointer from 5 to 10. Correct. Now what I told, realloc may have two possibilities. Okay, one is the block expands in place. Simple cases. So if this is having the initial 50, okay, again it will have more 5 in the same place. It will not use the new memory. Okay, but this will be garbage value. Okay, this will contain the garbage value. You have to reinitialize. Okay, but if it is moving to a new memory block, then it will be going to a new expanded region. Okay, from the old heap to the new heap. So old block needs to be freed. Old block needs to be freed. Okay, now there is something known as fragmented heap. Okay, now it will move to the block commonly in the fragmented heap. Now fragmented heap means there are some spaces left in the memory. That is known as the fragments. Okay, memory in a program's heap is broken into many small non-contiguous blocks. This occurs when memory is frequently allocated and then freed. Okay, frequently the memory is allocated, then it is freed. Okay, so it will have the fragments of the free spaces in between. So this is known as the unused space. So as a result, even if the total amount of free memory is sufficient, a program may fail to allocate a new block because no single free block is large enough to meet the request. So here you can see that this is the assigned space. Okay, then there is some free space available. Then this is the assigned space. Then there is some free space available. So in that particular case, what will happen? Common in the fragmented heap, if the space is not available, it will go to a new block, new memory location. Okay. Then you need to initialize again. Okay, so now we have got all the values from 10 to 100. Okay, so we got all the values from 10 to 100. Okay, and then we are using pre-release the memory. Okay, so this stack which stores the addresses of the pointer, this will be initialized to null. Okay, and memory returned to heap. So whatever memory was allocated to the from the heap, that will be returned to the heap. Okay, so memory is now reclaimed and cannot be accessed. This is what is the whole working of the malloc, calloc, realloc, and freeing the memory. Okay, this is very important concept in C to understand. Okay, about the memory. So is this clear to everyone? Malloc initializes the memory. No, it will give a garbage value. Can resize, on failure, fast allocation. Calloc, yes, all zeros. No, returns null. You cannot resize. Yes, you can resize if you are using realloc. And you can use the pointer for malloc or calloc, whatever you have used. It keeps the existing data, returns null. Okay, it will increase or decrease the memory dynamically. Free pointer. Okay, releases the heap memory. Okay, so this is all about. Yeah, tomorrow will be the main assignment. Sorry, quiz it will be. Okay, quiz. Assignment topics for these topics I will be giving you. Okay, quiz will be there. Yes, I will upload. Okay, I think it is already shared. You will be getting that. Okay. So this is all about. This is all about the malloc, calloc, realloc, and free. Okay. So we need to follow the best practices. Okay. Always check allocation results. If not pointer, then you have to give some message. Prefer size of pointer over size of data type when allocating. Okay, because that is dynamic pointer and not the static. Check for integer overflow when computing n into size of type. Okay, so use the size underscore t. Use calloc when need zeroed memory. Use a temporary pointer for realloc to avoid losing original pointer on failure, and that is where we have used the temp. Free every allocation exactly once. Okay, set freed pointers to null so that there is no dangling pointer issue. Avoid very large objects on the stack. Use heap for large buffers. Minimize lifetime. Allocate as late and free as early as possible. Okay, if not pointer, okay, then you free the memory. Okay, whatever has been allocated earlier. Be careful with pointer aliasing. Update all references if reallocating and storing pointer in multiple places. Okay. So this was all about the memory stack, then heap, static, dynamic memory, and these 4 functions. Okay, for dynamically allocating and deallocating the memory. Okay. Next is the preprocessor. Okay, so let us just start with this preprocessor. Okay, some of this already we have done, but whatever okay needs to be known in preprocessor, okay, that we will do it. The C preprocessor is a tool that runs before the compiler. It processes the source code to perform text substitution, file inclusion, and conditional compilation. So output of pre-processing is modified source code, which is then compiled by the C compiler. Okay. Key points: runs before compilation, operates on the source code text, not on machine code, handles directives starting with hash. Already we did this n number of times. Hash include, hash define. Okay, hash include, it replaces with the contents of stdio.h. It contains printf scanners. Hash define pi, either you use constant or either you use hash define. It will replace all pi with 3.1415. Okay. There are some pre-processing stages in C. First is the file inclusion, like hash include. So it will include the contents of that particular header file. Macro expansion, like hash define pi, it will replace the value of pi to 3.14. Okay. Conditional compilation, compile code based on condition. Okay, like hash if define, debug, hash and if. So we'll see, okay, this particular demo tomorrow, how you are going to make use of some of these conditional compilation, like hash if define, then you need to do this, hash end if, because this is the starting of if, this is the end of if. Line control and miscellaneous directives. Directives like hash line, hash pragma, hash error. Pragma pack 1 we have used, okay, so that the padding is not included in the structure or union. Hash pragma can also be used to give error, to give some messages, okay, or hash error. Okay, so these are some of the pre-processing stages in C. Okay. So we will be doing this all tomorrow. Header files, we will understand how to create our own header file and how to include that in the program. Okay. And some of the other pre-processing, right? So now you will have the quiz. Okay. So Shushmita, you can share the quiz again for 10 questions.
Yeah, sure, ma'am. I'm sharing it.
Yeah. So 10 minutes, last 10 minutes are remaining. So you can give the quiz. Okay. Cost of realloc means what? You need to reallocate the memory block. Initially, 5 integers space was allocated. We want 10. Okay. So 5 more will be provided in the same block of memory or in the new block of memory. Okay. So we will do that later. Okay. So now quiz you can give. Okay, attendance is shared already. Quiz is already shared. Okay, quiz is already shared. And attendance link is also shared. Krishmita, you can share the attendance link once again.
Yeah, okay, ma'am.
Attendance link will be shared once again. Okay, Kaustav. So more 2 minutes only, Shushmita, then we can end the session.
Sure, ma'am. We can wind up for the day.
Yeah. So only 2
Yeah.
minutes left. Okay, those who need to complete the quiz.
Okay. So, like students, as you all know, tomorrow is a day 15, that is last day. So we are conducting the assessment for 50 marks. It's a MCQ question, 50 marks. It will be around 45 minutes. So as usual, regularly, ma'am is going to take a session till 8:15. After 8:15, in the same meeting, I'll be sharing the assessment link in a chat, both Zoom and YouTube. So there will be the assessment for 50 marks. It's all MCQ question. So I request please everyone to join the session by tomorrow and inform your friends as well.
Yeah. Right. So that will be the final quiz. Okay. Which will contain all whatever we have, done with the C topics. Okay, so it will include all the topics questions, right? So it will be, Shushmita, how many questions?
50 questions, ma'am.
50 questions,
50
right?
questions, 50
Yeah.
marks. Yeah.
50 marks. Okay. 45 minutes, right? Yeah.
Yeah, it's around 40 to 45 minutes.
40 to 45 minutes. Okay, fine. Fine. So we can end the session now. Everyone, thank you all. So we will complete the session tomorrow with the final quiz. Okay. And yes, I will also share the assignments and the mini project tomorrow. Thank you, everyone.
Yeah, thank you, ma'am. Thank you so much. Yeah, dear students, as I hope you all understood, kindly join the session by tomorrow without any fear. Okay. Thank you all. We'll wind up for the day. Good night.